Okay, so this evening, what I wanted to do was just to take a little bit deeper dive and get a little bit more specific where needed on the homework problems that you have. So the first homework problem that we have for assignment number 1 is going to be the kinematic diagram for problem 1-1, which you are going to find is on page 25 at the end of the chapter 1 in your kinematics book, okay? And it's the very first problem here. And the first problem here says that we have a mechanism where we open the door on a heat treat furnace, okay, as shown right here. They want us to draw the kinematic diagram, and then they're telling us the end of the handle needs to be a point of interest. So that's this over here. So this is our handle. And basically what we do is you're going to notice that this handle pivots about this point right here, which is attached to the frame of our heat treat oven or furnace here. Okay, so that would mean that this point is not going to be rotating. It'll be stationary. So this will be a frame member for us. Okay, now that handle actuates then as we can rotate it about that center. So if we rotate it down, then this side is going to go up, which is going to raise the door on that heat treat furnace. So the door is going to be between these two vertical slides, if you would. So that means that this is going to slide vertically up and down. Okay, so if we pull the handle down, the door goes up. If we rotate the handle up, that means the door is going to go down. Okay, so this door is going to act like a slider. Okay, so as we look here, are there any questions on how to represent this particular problem using our standard kinematic symbols and such? And it's open for everybody to ask. So I just want to make sure. If not, I don't want to waste anybody's time. Okay, I'm watching the chat. I'm not seeing anything. Okay, so if there isn't any questions about that one, then as we move down to our next problem, which is down here, this is 1-3. This is the stadium seat, okay? And this chair is a folding chair that the bottom kind of goes down, and then you can flip it up, okay? It is attached in two places here to what we would consider the frame. These are stationary parts. So this point right here, the actual seat itself is attached to with a pin joint, okay? And then this point up here, which is one of the other links in the mechanism, is attached up here to the frame, okay? So we would have the frame attached in two places, considered one link. Okay, that would be our, if you would, number 1. Okay, and then our number 2 would be the seat itself. Then 3 is going to be one of these rigid links, and then 4 is going to be the last rigid link. Okay, and then this seat is then going to pivot, up and down, up and down. So representing this one, no sliders on this one. Does anybody have any questions of how to show that? Okay. All right. Now, in addition to the diagrams, remember, you also have to do, and that's what the second problem is here. So problem 1-3 is the diagram. Okay. And then making sure we're putting all of our labels and such on. And then the second part is going to be, this is the corresponding calculation for the degrees of freedom. So that's why it says for problems 3 and 28. Okay, since there aren't any takers for that one, I'm going to turn the page. And our next problem is the toggle clamp 1-9. Here we have a toggle clamp, and it's used to, hold down a workpiece that's being machined. Draw the kinematic diagram of the mechanism. So this is going to be similar to the other toggle clamps that we saw when we did our practice problems. And in this case, the handle is just, configured a little bit differently. And then the part out here might look a little bit different as well. But actual operation, we're going to notice that this handle right here pivots around this fixed point down here, which is going to be a frame member, okay? And then you're going to notice that as we rotate this down and up, as we rotate it up, our clamp is actually also going to rotate up. And then as we go down, our clamp is going to go down. So the clamping is similar, but the mechanism on how it's set up is a little bit different. So we've got a handle, okay, connected to the frame. Then we've got this, I'm going to call it the connecting link. And then we're going to have the clamping link. It's also going to be connected to the frame, okay? So 2 connections to the frame. And that means we're going to have 1 is our frame, 2 handle, 3 connecting link, and then 4 would be the clamp here. Okay, so we would have 4 links in our mechanism. So as we look here, are there any questions on this particular mechanism in creating the diagram that you may have? No questions, no questions. Okay, thank you. Thank you. All right. If there aren't any questions on that one, then we'll peek to the next one. Okay, I'm going to zoom in just a little bit. This one, and I believe we talked about this one when we were together the last time as well. You're going to notice that this one is that child's digging toy, and this one is going to have more than 1 degree of freedom. Okay, you should get a degree of freedom of 2. Okay, and we need it. We're going to get a degree of freedom of 2 because we actually have 2 handles here for which we need to operate this. So that means we have to do 2 things for the mechanism to actually, do its final function. And so not that 2 is bad, but like we had expressed in our lecture, 1 is always optimal, right? But if it's 2, it's 2, right? So in this case, it is going to be 2. So make sure that you get 2 for your degrees of freedom on this one. But are there any questions setting up this one? We did do a little bit of an explanation the last time, but as you've maybe gotten into it, are there any questions on setting up this diagram? Because I'm happy to sketch it out for anybody who wants to see it.
How would you set up the shovel side?
Oh, sure. Over here.
Yeah, because I was trying to think of how to represent
Oh,
the
this
shovel
guy.
at the
Okay.
lower.
Well,
Yeah, because
what I'll do is I'll kind of start the whole mechanism. All right.
okay.
And we'll kind of end there and I'll be able to incorporate that. Anybody else? So I've got Josh is interested in seeing that. Looks like David would like to see this one. Okay. All right. Good. So what I'm going to do is you're going to just kind of talk this through. First of all, the seat itself, notice that the seat itself is part of what actually attaches to the ground, which is going to be the part that's not going to move. So that means that the connection there to that frame is our frame. All right. So that's going to be the frame itself. Then attached directly to the frame is going to be this like T section that we see here. Okay. So that's going to be a continuous member or a link that's going to be attached directly to the frame. Then attached to that is going to be our second handle. Okay. Then another connector. And then lastly, like that shovel portion. Okay. So what I'm going to do is I'm going to go over here. And I'm just going to, now, as you hand in, as you know, you're going to be handing everything in using AutoCAD. But for time's sake here, I am going to just sketch these out and then you would translate it over to AutoCAD. So this is problem 1-10, right? Yep, 1-10. And I'm going to start down in the bottom right-hand corner, if you would. This is going to be my frame, okay? And then I'm going to go directly up, okay? Then I'm going to kind of something like this. And I think the last time, I'm actually remembering, the last time we were together, I kind of showed you, an option for, illustrating what this would look like, because this is a little bit different looking part. It's not really just a single triangle. but we want to show that it's a continuous part. So we can't just use lines either. Otherwise it'll look very, different, separate pieces. So this is kind of how I'm representing our T, which is the first member right here. Okay. So now I'm going to add, and down here is where it attached to the frame. Now I'm going to add the pin connection for that vertical handle. Okay. So I'm going to add that right about here. And then on the very end point is going to be the where the shovel portion is going to attach. So then I'm going to put the next handle going straight up. Okay. This one I'm going to make a little bit of a triangle just because the pin connection is right here. And then that handle extends above. So if I would just put my pin connections here on a straight line going up, I have the tendency this might look like two separate parts. So I want it to look like a continuous handle. So I am going to draw kind of that triangle-y looking part so that it looks like a solid piece, that extends beyond the pin connection. Then I'm going to go straight up here, and this pin connection is going to go to the end here. And this is that connector in between. Okay. So what I've got in place right now is my T. Okay. And then I've got the vertical handle, and then I've got this connector here to what's going to be the shovel then. Okay. And then Josh, your question was, what should that shovel look like? So this is part of the shovel right here, and I need to make it a continuous piece. So it doesn't have to be just a triangle. You can kind of, what I would do is probably go something like that. Okay. And then this would be a continuous piece here. So my parts then would be 1 for my frame, 2 for that T shape, 3 for my handle, 4, I'm going to call that the connector, and then 5 is going to be that shovel or scoop. Okay, so there's going to be 5 links on this mechanism, including the frame, right? Then I have to letter my joints. Again, I like to start from my input, which would be over here. So I'm going to start A, and again, these can be kind of arbitrary. B, C, oopsie, C. I said C, I didn't write C. And then D, and then this would be joint E. Okay. Now for this part, I'm going to kind of finish this up. Since we have this completed, first of all, are there any questions on the diagram itself? And then we might as well just finish it up and do the calculation for the degrees of freedom. So that equation is going to be F is equal to 3 times n minus 1 minus 2 times JP. N is the number of links. JP is the number of primary joints. And then as we know, it would be minus JH, which are higher order joints, which we're not going to be encountering in our problems right now. So we just kind of truncate this. So our number of links here, we have 1, 2, 3, 4, 5. So this is going to be 3 times 5 minus 1 minus 2 times the primary joints. So I've got A, 1, B, 2, C, 3, D, 4, and E would be 5. So if I multiply this out, my F is going to be equal to 3 times 4, which is 12, minus 10. So this is going to be 2. Okay. And which goes along with, what we're expecting, because we can see that there are 2 handles here. So there's 2 degrees of freedom in order to get this mechanism to do the scooping and such that we want it to do. Okay. So is that helpful? Is that any questions on that at all?
No, that was pretty helpful.
Either part. Okay, good. And I know that part of like, how should I represent that? We want to use the standard symbols as close to as possible, but you know, this really isn't standard and this really isn't a triangle, but it represents it in a simplified way because a lot of times, as I stated, when we're at this point in the design process, we don't really even know what these elements are going to look like. We're kind of going backwards with these by having finished mechanisms and now we're making diagrams for them. So, yeah. All right, so that's 110. Any, before we move on to looking at our next one, is that anybody else have any questions? Okay. All right. Our next problem is 111, and the statement is down here at the bottom of the column. It's a reciprocating saw. We want to draw the kinematic diagram, and the diagram is up at the top here. Now, when we talked about this on Wednesday, I told you that you don't want to draw the circle. Like the circle is like a little flywheel that is attached, if we would, like into the screen. So in back of this flywheel, there's a little electric motor, okay? And that electric motor is rotating. And all that that is doing is it is connecting to what I'm going to call is the connecting link. So we don't draw the circle. We're just going to draw from the center to where it would connect as just a straight radius, like it would be a straight link, okay? That's how we would represent that. And then we would have another just straight link. And then this would be our slider going in and out, in and out, in and out. You don't need to draw it all the way to the edge of the blade unless you would want to use that as a point of reference, but it would just be a simple slider, you know, that's connected to that point there. So kind of looking at it in that sense, any questions about representing that one?
I have a slight question.
Yeah.
Should we do anything to represent how much bigger it is than just that section, like to show the back, how far out the back it goes? You won't use a point, obviously, but you'd use like
You
two
mean
lines
like the
coming together.
handle and such?
Yeah,
No, we're just representing just the mechanism here.
just the
Yep,
mechanism.
so we're
Okay,
just there. So this center would be your frame because we're looking at that as not moving. Yes, the whole thing isn't like, you know, attached to something, but this would be like the starting point where things are rotating around. So the
sure.
center of this would be your frame. And then you would have the you know, the link for the radius and then the connecting link and then the slider.
Okay.
So
Well, I
like a
mean, that makes
crank
it way
slider
easier.
mechanism.
So
Yeah,
that's fine with
yes,
me. Just
exactly.
I wasn't sure if you, for a sense of size of like, because for other stuff, like when we make the, instead of a straight line, we'll make like the triangle to show that it's got how it.
Oh, right. I know what you're
Yeah,
saying.
yeah.
Yep, just focusing just on this particular mechanism in there to make that blade go back and forth.
Okay.
If you were designing the entire hand tool, there might be, you know, considerations from the design standpoint of, you know, space and you know, length to make sure that it's going to be ergonomically correct for, you know, an adult to actually use. But no, in this case, we're just focusing just on the mechanism to make that blade go back and forth. Okay. Any other questions? Okay. All right, then there is one last one. And I think the last time we were together as well. Now, just to be clear, down here, 124, the problem statement is here, and this is for the sewing machine. This is not the sewing machine directly below it, okay? You want to go up to the top of the next column, and this is the illustration here, okay? Now, this problem is actually a reapplication of the 110, the reciprocating saw mechanism, but now it's actually vertical. Okay. So here, if we would see in back of this flywheel, we would have our electric motor. It would be rotating about this point. And again, we're not going to draw the circle. We're going to draw that, oh, it's just a radius from the center of rotation to where we have our pin connection for our connecting link. And then we just have a slider right here attached going up and down. Now, our slider technically is much longer, but this problem doesn't ask us to worry about any special interest points, okay? So you can just show this as a simple slider, just like we would, you know, just a normal slider. You don't have to extend it unless you would want to, So that is how you would, you know, like look at or kind of break down each one of those elements there. As you look at that, are there any questions on the diagram for 124? Happy to sketch it out if you like.
I do have one question.
Yeah,
So if you were to extend that bottom part, it would just be like a long triangle, right? Just starting from
yeah,
the
you
yeah.
could. You would have the rectangle right here to represent the slider, right? And you're saying go all the way down and up, but you want to show the slider so that it looks like a rectangle.
Yeah.
Does that make sense? Yeah. Because then you want to show that left or the right or the left side so that we know that it's going to be a vertical orientation. Is that helpful?
Yeah, thank you.
Okay. All right. Any other questions? Okay. All right. Now, those are the diagrams, if you would. And then don't forget that each one of those has a corresponding second part of the problem that is going to be calculating the degrees of freedom. So those are here. Now, the last two questions that you have in this problem set are going to be the case studies. And for the case studies, as we had talked about last time, you're going to look at the mechanism we see here, and they give you a little bit of an explanation. But basically you want to kind of look, this is a motor, it's going to rotate around. This is going to be our, if you would, crank that's going to rotate around, connecting link. And then we've got this slider going in and out, in and out. And basically what it's doing is it's distributing these ball bearings into, you know, little chutes that are going to then, you know, place them wherever they need to go. Okay. So once you kind of get an idea of what that mechanism is doing, now what you want to do is you want to answer the 6 questions here that they have. And as I had stated the last time we were together, when you answer these, I want you to think about emailing your boss, okay, when you're working on an industry. And your boss wants to know the answers to these questions. So when you answer these questions, that's the frame of reference I want you to use. So I want you to be relatively brief and to the point, but making sure that you're answering the questions so that if somebody, you know, comes back and wants to just use the email, they should be able to get through the answers to these questions without having to come and talk to you further about your answers. Does that make sense? Okay. And then the second case study, here's the problem statement, but the illustration for our mechanism is on the following page. And this one has 9 questions that you're going to answer. And again, that same frame of reference where you're sending an email to your boss and they're wondering about the mechanism that we see here. And something that I wanted you to do, and this is a total optional thing, and you don't even have to do anything as part of the assignment for this, but check out your own toilet at home and see how it compares to the operation of this, and see if there's some similarities or if it's different. And so it just kind of brings to light, you know, a common mechanism. You might not always think of the water in your toilet tank as being, you know, an application of what we're doing here in kinematics. So anyway, so that's that. No diagrams to make for these last 2 case studies, just answering the questions. Okay. So with that kind of takes us to the end of kind of the explanation, or going one by one through these problems for assignment number 1. Does anybody have any additional questions or anything as we kind of look here? Okay. All right. Then with that, this evening, then the rest of the time that we have together is for you to work independently, have me available to answer any questions that you might have. And then, you know, I can go through things and, you know, kind of go under my camera and such. So if there aren't any additional questions, then what I'm going to do is I'm going to stop our recording here.